Welcome to the R video tutorial on regression in R. This is part one of a two-part series. This one we'll learn how to do simple linear regression in R. Okay, so let's jump right in. We're going to use the Sydney Hobart race data that we've used before. I have it on my desktop and I'm going to read this in. It has a header in it and its separator is a tab. So let's read this in real quick. We can look at it and see what our variables are and what's in it. We've used it before, so you should be familiar with it. We're going to be interested in year and how long it takes the time it takes to run the race. So let's do a quick plot of this, because every time you get some data, you should do a plot of it. All right, so let's see. We have Sydney 1, and we're interested in our X variable, which is the year, right? We're using year to predict the time it takes to run the race. Okay, here I'm not really going to dress it up too much because we've done that in the previous video, but we want to just look at the picture here real quick, and you can see it's generally a linear negative pattern, maybe moderately strong, but there is clearly a pattern here, and we're going to try to fit a line to it, which we did in the previous video, but we just added the line. We didn't actually interpret the line, which is what we want to do here. All right, so let's add a thing here. It says plot the data. Now that we'll have that, then the next thing we want to do is actually fit a regression line and get the information out of it in R. So what I'm going to do is I'm going to call this SID1 reg, because it's a regression, and we're going to use the LM function, which stands for linear models. Now, here's the key. When you do this, you have to pay attention to what's X and what's Y. Here, you should put in here Y tilde X. Okay, that's going to be the notation we're going to use in here. So let me put a space in here, and then when you do a plot, it's X comma Y. So these are going to be reversed, and this is the most common mistake people make. So we're going to do SID1, and we're going to do our Y variable, which is time, and our X variable is SID1, and year was the predictor for it. And there's another way to do this. You can put a data statement on it and whatever. But here we're just trying to be very straightforward so you can see what we're doing. Just notice that these variables here, this statement, is the reverse of this statement. Otherwise, things won't work well, and when you try to plot the line, it just won't work. All right, so let's run this. And notice absolutely nothing happened. However, if we came over here, you could see something came up, and notice it's a list of 12. And what we can do is first see what's on the list. So let's go down here, or put it in the code here, names, SID1 reg. Okay, and this will show us what is attached to this list. So there's coefficients, residuals, effects, ranks, fitted values, assignment things, degrees of freedom on the residual, the X values, X levels that we used, terms, and an actual thing of the model. Now, what we're really interested in are the coefficients. So we could actually ask for them directly like this, but it's actually not that useful to grab them directly. As you quickly see, here they are. Coefficients. Now, what I would rather probably have is if I use the conf int function, and then I can put in here my SID1 reg, and let's see what pops out of this thing. So give this a run, and look, not only do I get the intercept, I don't actually get the value of the intercept, but I get a confidence interval for the intercept and the slope. And it's a 95% confidence interval, and I can change that if I wanted to. And the conf int function is quite useful for doing things like that. And it's pretty generic in that it'll work in lots of places. So create a confidence interval for the regression coefficients, if I can type. All right, so we've done that. We've seen what those look like. They're 95%. You can change the confidence in them by just changing another statement here if you wanted. So, comma, and let's see. If I come over here, because I can't maybe remember what I'm supposed to do, I believe it's level, but we'll find out. We can come over to help, and we can do conf int. And when I pop this open, we will quickly see, oh, yep, its level is what I'm interested in. So always use the help when you're unsure. So I come back over here, we can type in level, and we can make this 0.99 if we wanted and get a different confidence interval for each. Now, usually we're not terribly interested in the intercept. We're usually more interested in the slope unless the data spans 0. But notice that this interval here is wider than this interval here. And it should be because it's a higher confidence level. All right, the next thing we might want to do is hypothesis test. And this is a little more interesting to do, but we can do this on regression coefficients, because that's usually what we're interested in. So to do this, all we have to do is summary. So our summary function comes back up, and it's pretty dynamic in the sense that it has a lot of information attached to it. So if I just run the summary of this, you will see a whole bunch of information pop up here. And I'm going to scroll this up here real quick so you can see what comes out. It gives you basic information, the 5-number summary for the residuals, and it gives you the coefficients, the estimates, gives you the standard error, a t-value, and a p-value. And this p-value is for testing whether or not that you're equal to 0. So the regression coefficient is equal to 0. And rarely are we interested in the intercept, because unless the data spans 0, and this it doesn't, because this is years. It didn't start until the 1940s. The year 0 would have been the year Jesus was born. I don't think they were running the race at that time. But anyway, they might have been, and we'll talk about that here in just a second. But here we have the coefficient, or the p-value associated with the regression coefficient, and it says it's highly significant under anybody's level of significance. All right, so let's play with this just a little bit more so that we can see how to peel more information out of this. So one of the things I might want to do is determine what our y-intercept is and our x-intercept. So our y-intercept, we already have it. It's actually right here in this. Okay, so let's see here. This is our y-intercept, and this is in minutes. Okay, so how many minutes is that? Or days is that? Well, you'd have to convert this from minutes to days, and I'll let you do this, but you can see it's not a very short amount of time, and this is the amount of time, the predicted mean amount of time to run the race in the year 0. Okay, so you can imagine Jesus has just been born, because that's what we built the Gregorian calendar on, and some Aboriginal folks have jumped on their boats, and they're racing all the way from Sydney, which is in the sort of the middle part of the eastern side of Australia, all the way down to Hobart, which is in Tasmania, which is at the bottom. And so they're sailing through the Pacific Ocean, the South Pacific, to reach Hobart. It really doesn't make sense, and that's why I ramble on about it. We don't really care about it. And we could put here, in this case, it's kind of nonsense, because we don't really have any data about it either. So this is nonsense, and it's a version of extrapolation. So we wouldn't want to do that. But if your data does span 0, it could make sense. Okay, and then we have our x-intercept. And you say, x-intercept? What's the x-intercept? This is where y equals 0. And we can see what this would be. Now, if you do a little bit of algebra, you can play with this. But it is, let's see, if I had a regular line, it's like negative of the intercept divided by the slope, I believe. Okay, so if we set that equal to 0, so this could be equal to the negative of the intercept. So now we have to figure out how to get a hold of this thing. So I'm going to do SID1 reg. I'm going to get the coefficients, and I'm going to get the first one. Okay, and then I'm going to divide it by the second one. SID1 reg, and divide it by the slope. And then what did I say I had to do is it had to be negative of that. Okay, and let's see what this produces us. If we were to run this, it doesn't like us because I put SID reg 2. I didn't actually put the coefficients. So I need to grab this coefficients and add it in here, because just typing things away makes you feel good, but sometimes it's wrong. Okay, so what this says is that if we were to continue this line into the future, for those of you watching, it's 2018 when I'm recording this, but the intercept here says that in 2049 it will take 0 minutes to run this race, which might be true. Maybe we'll have teleportation by then, and they can just take their boats from Sydney Harbor and just immediately teleport them all the way to Hobart. But, and again, this really doesn't make sense because this is, again, predicting into the future, and it's extrapolation, and it's nonsense. So keep that in mind when you're doing these things, because lots of people like to make predictions that really the data doesn't support, because we don't have any data out in the future, right? It hasn't happened yet, so we don't know. And if you really come back and look at the plot, you stare at it just for a second, you'll realize it's actually curving here. It's kind of leveling off a little bit more than it was before. All right, so this is the first of the 2 videos. We will jump to the next one and finish off doing some basic things in regression.